So this video is on the breakdown of the ozone layer. And our aims for this video are to know how chlorine free radicals form in the upper atmosphere and to explain how ozone is decomposed via the free radical substitution mechanism. So first, if you've watched the free radical substitution video, you'll know that chlorine free radicals are formed, to form haloalkanes are formed from chlorine splitting apart under the presence of UV light. But in the breakdown of the ozone layer, it's not chlorine that's splitting apart, but molecules called CFCs, which are gases that were used in fridges and aerosols in the 70s and 80s until it was banned. And basically a CFC stands for a chlorofluorocarbon. So an example of this would be, for example, this following molecule. So this would be 111-trichloro-222-trifluoroethane. And when UV light hits this, the carbon-chlorine bond will break, and that will have the same effect as when chlorine breaks by creating a chlorine free radical and the following free radical, CF3CCl2 dot. So basically, this bond here, or this one, doesn't matter which one was chosen, but this bond here is broken by the UV light to create a chlorine free radical. Now, if you don't know what a free radical is, then watch out my free radical substitution video. But basically, this chlorine free radical can then cause a lot of damage in the ozone layer by the mechanism that I'll show you. So the first step is that initiation step, and then once that initiation step has happened, the chlorine free radical, once it bumps into an ozone molecule, which is O3, it will break apart that ozone molecule to create just simple oxygen gas and ClO dot. Now the reason it can do that is firstly because the chlorine free radical is so reactive, but also because O3 is the following molecule. It has a double bond between two of the oxygens, but a single bond between the other two, and this bond is very weak. It's this bond that absorbs the UV light that the ozone layer absorbs to protect us. But that bond, because it's very weak, will also break when the chlorine free radical reacts with it. So our next step, once that's happened, is that free radical that's formed is ClO dot, and it will react with another ozone molecule to create two oxygen molecules and the chlorine free radical again. So because this chlorine free radical is regenerated, this reaction can happen over and over and over again, like a chain reaction. And so just only a few CFC molecules, once they break apart, can create a few chlorine free radicals, and that can break apart many thousands of ozone molecules. Now overall, if you look at this equation, the free radicals cancel out. If we add the two equations together, we get 2O3 just breaking down into 3O2 with a chlorine free radical catalyst. So let's have a look at a couple of exam questions which is based on this. So the first one here says chlorofluorocarbons are used as refrigerants in the upper atmosphere. Ultraviolet radiation breaks bonds in the CFCs. An example of a CFC is 111-trichloro-2,2-difluoroethane. Draw the displayed form of the CFC. So first, ethane is two C's. You've got 111-trichloro, so you're going to have 3 chlorine atoms on this first carbon. You're going to have this difluoro, so you're going to have 2 fluorine atoms on the second carbon. Remember, carbons always make 4 bonds, so our last bond is going to be taken up by a hydrogen. Then it says, identify a bond in a CFC that is broken by ultraviolet radiation to produce a reactive intermediate. Give the name of this reactive intermediate that catalyzes the decomposition of ozone, write an overall equation for this composition of ozone. So, our bond that breaks, as we've discussed, is our CCl bond in a CFC. The name of the reactive intermediate formed is a chlorine free radical. And our overall equation which is just that one equation which shows the breakdown of ozone is ozone, 2 of them, turning into 3 oxygens. Sometimes you'll see longer questions on this topic. So here is a long question. It says, explain how chlorine atoms are formed from chlorine-containing organic compounds in the upper atmosphere. Explain with the aid of equations how chlorine atoms act as a catalyst in the decomposition of ozone into oxygen. This is worth 6 marks. So first, the first mark is for talking about CFCs. And that CFCs are chlorofluorocarbons, and that they contain CCl bonds. The next mark is saying that CCl bonds break to form chlorine free radicals, Cl dot, when hit with UV light, and that's your third mark. So your first mark is here, talking about CFCs containing chlorine carbon bonds. Second mark saying the chlorine carbon bonds break to form these Cl dots. Third mark mentioning UV light. Fourth mark is your first propagation step, so Cl dot reacting with one ozone to form ClO dot and an oxygen. Your fifth mark is for your ClO dot reacting with another ozone to form 2 oxygens and regenerating your Cl dot. Another mark can be said that Cl dot acts as catalyst. And another mark could be for the overall reaction of 2O3 making 3O2. So there's quite a lot of there you can write down, quite a lot of points to make. So if I show you again, your first, so your marks are for first, CFCs containing carbon-chlorine bonds, saying that they break to form the Cl dots with UV light. Your first propagation step, second propagation step, talking about how Cl dot acts as a catalyst, and you get another mark, can get another mark for the overall reaction. Obviously there's more than 6 marks there, but any 6 of those will get you those 6 marks. Finally, they could ask you why something is more environmentally friendly than a CFC. So here you've got halothane and disfluorane. It says use a formula of these 2 anesthetics to help explain why desfluorane is considered to be more environmentally acceptable anesthetic than halothane. And basically what they're getting at here is that desfluorane does not have a carbon-chlorine bond, or doesn't contain chlorine at all, whereas halothane does. So you can say that desfluorane does not contain CCl bonds, so therefore will not produce chlorine free radicals, whereas halothane will.